10 now, and with Unit 10 we begin to work with our system of natural deduction. This is in some sense the heart of the course. We've been working with propositional logic for the last couple of units, and now we're ready to begin to try to solve problems which are symbolized arguments to show that the conclusion can be derived from the premises following the rules of inference and the rules of replacement that compose our system of natural deduction. Natural deductions, you'll recall, are in fact series of steps that lead us in accordance with the rules of the system from the premises of an argument to its conclusion. And since we know, according to the rules, that each step is a valid step, when you assemble a whole series of these, you're ensured of validity again. Therefore, we know that the conclusion will follow. Now, in Unit 10, we will be concentrating just on the 8 rules of inference, and in fact, the first couple of problems will start with simply the first 4 of those rules. What I'll be trying to do, besides simply solving the problem, is to give you some sense of how to go about building up a strategy for each of the problems that you'll need to solve. So let's begin now with the first 4 rules. Remember, these are modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. And we're going to try to first provide our required justifications for deductions that already have been worked out. So here we have a deduction. Notice lines 1 through 4 are the premises, and E is the conclusion we're hunting for. And 5, 6, and 7 give us the steps that lead us from the premises to E. So we need to come up with the justification for line 5. That is, line 5 can be derived from lines 1 through 4 in accord with at least one of the rules of the system. So you ask yourself, where did not A come from? Can I generate not A from the information in lines 1 through 4? Well, think of the rules and focus here on line 3 and line 4. Notice line 4 negates the consequent of the conditional that's on line 3. And you should recall the rule of modus tollens will allow you to infer from a line of form 3 and 4 a line of form number 5. Therefore, the justification for line 5 is lines 3 and 4 modus tollens. Okay, now how did we get B and C? Well, first you look back at the premises and see where B and C occurs. Notice it occurs here. It also occurs here. So what further information do we already have that allows us to derive B and C from either line 1 or line 2? Well, we're not really going to easily get it from line 2, are we? But notice that we already have derived not A, and so we can operate on line 1 with not A through the rule disjunctive syllogism to give us the disjunct B and C as an answer. So line 6 is justified by citing line 1 and line 5 and citing the rule disjunctive syllogism. And now our final step, how do we get from lines 1 through 6 to the conclusion E? We do that by noticing that E follows if we know B and C. That's what line 2 tells us. And of course line 6 tells us that we know B and C. Therefore, lines 2 and line 6, along with the rule, modus ponens, will allow us to derive our conclusion E. Okay, that's not too bad. Now we use pretty much the same kind of strategy with each of the problems. Of course, the problems are harder when the lines are not given to you, and that's what we're going to try to do now, fill in the lines as well as the justifications. So we want you to use the first 4 rules of inference to derive the conclusion of the following symbolized argument. So this is an argument with 4 premises, and what we need to do is get ourselves to the conclusion G hooks E. You always pay attention to the conclusion because that determines how you're going to solve the problem. You need to go back into the premises and look where the information G hooks E or its components occur. So you find G here in line 1, and you notice that E occurs only in line 2. So some manipulation of line 1 and 2 is going to have to go on in order to get ultimately to G hooks E. Well, notice again that the inside conditionals on both of these lines have the correct form to apply hypothetical syllogism to them. In other words, if we could alter lines 1 and 2, removing the P and the Q at the beginning, we would have two lines then that would allow us to get G hooks E by the rule hypothetical syllogism. Remember, to do hypothetical syllogism, there has to be a shared component. In this case, it's the T, and that component has to occur as the consequent of one conditional and the antecedent of the other. So now we know that we want to generate G hooks T and T hooks E, and will, after we do that, be able to get to the conclusion with the move hypothetical syllogism. So now the question is, how do we get these two lines? Well, if we could drop the P off and drop the Q off, we'd have them. And notice that the other information in premise 3 and 4 just is P and Q. And reflect upon it, and you'll think of the rule modus ponens. Modus ponens could be applied with line 3 and 1, for example, to get G hooks T. Also, once again, with Q and line 2 to get T hooks E. So, here's the strategy. We're going to do two moves of modus ponens, and then we're going to do hypothetical syllogism to get the conclusion. So let's write them out. Let's do the modus ponens step with line 1 and 3 first. That will give us line 5, G hooks T, and we need to justify that then. 1 and 3, modus ponens. Now we do exactly the same strategy on line 2 and 4. That will give us T hooks E, and we cite 2, 4, modus ponens. And now notice we've got the two lines that we were looking for in order to use hypothetical syllogism. So line 5 and 6 gives us our answer, G hooks E, 5 and 6, hypothetical syllogism. There we go. Now you'll notice that in effect what we're doing here is working backwards. We're thinking a strategy out step by step and working ourselves back from the conclusion to the information that we have, namely the premises. Once we figure that strategy out, then you write the lines down simply by inverting the order of that strategy. Let's watch how this happens again with another problem. Here again we've got 4 premises, and we're looking for X. So you scan the premises to find out where X occurs, and it becomes clear that it has to come out of line 4 because there's no other X available. How would you get X, which is the consequent of a conditional in line 4, on a line by itself? Well, modus ponens could generate X from line 4 if I had C or B to work with. So now the question is, can I get C or B? Well, you look around and see what you have to work with. Here line 2 has C or B on it, and if I could get not A, I could then apply disjunctive syllogism to line 2 and get C or E. So now the question is, can I get not A? Well, look at lines 3 and 1. Lines 3 and 1 are of the form modus tollens. Line 3 negates the consequent of this conditional. Therefore, I can get not A through a use of modus tollens. So now I basically know my strategy. I'm going to first do modus tollens on lines 1 and 3. That will give me not A. 1, 3, modus tollens. Now I have the negation of one disjunct of line 2, which gives me C or B by lines 5 and 2, disjunctive syllogism. And now what do I need? I've got to get to the X, right? So I've got the antecedent of this conditional, and X is the consequent. I can infer the consequent, having the antecedent, by citing lines 4 and 6. modus ponens. Okay, so once again you'll see we're doing this backward strategy, working back from the conclusion to the premises. And I think by now you will know that a good grip of the rules is absolutely essential. When you look at the problem, when you see the premises of the problem, you're going to need to be able to bring up in your mind the rules that you think can be applied to those lines. So let's move on here and try to expand our horizons a bit and use all of the 8 rules of inference now. So the ones we've already used, plus constructive dilemma, conjunction, simplification, and addition. And let's first start by solving a problem where we only need to give the justifications. Start with an easy thing and work our way up. So here's our conclusion, P and R, that's what we're hunting for. And the first line is Q or not S. How do we get Q or not S from lines 1, 2, and 3? Well, you hunt for it and you find there it is right there. Right? And it occurs as one conjunct of a conjunction. So you can move directly from line 1 to line 4 with the rule simplification. That allows you to infer one conjunct when you have a conjunction. Now we need to get to not S. Notice that we can now use line 4 in our attempt to get not S, and that's in fact what we are going to use along with line 3. Line 3, you'll see, negates the one disjunct of line 4, and therefore we can infer not S by disjunctive syllogism, 3 and 4 disjunctive syllogism, because if this disjunction is true, and we know that one of its disjuncts, the Q, is not true, that's what 3 tells us, then we know that not S must be true. Now where do we get the Q? Well, we have not S that we've now derived, and if you look around in the premises, you'll notice that we have this disjunction, S or Q. Not S negates the S, therefore Q can be derived, again by disjunctive syllogism, this time on line 2 and line 5. Same principle as the one we used before. Now, how do we get to Q or P and R? Well, you might need to think about this for a moment. We don't have any P or R in here. This is a kind of funny problem, isn't it? But you should remember the rule addition. If you know Q, you can add to Q anything, including a complex such as this conjunction. So 7 we get simply from line 6 and addition. And now I'll let you in on a little secret about this particular problem. Notice that we have derived a contradiction. We have on line 3 here, not Q. We also have Q, it's contradictory, on line 6. It's interesting to point out that from a contradiction, anything follows. So this problem is an interesting case where from premises that don't even involve P and Q, you can derive P and Q as a result of this unusual circumstance that we have been able to derive a contradiction. This strategy actually will become more important when we get up to our last unit, Unit 13. But for now, let's finish off this problem. We go from 7 to line 8, P and Q, by noticing that line 3 negates the Q on line 7. So once more, we have a case of disjunctive syllogism. There we are. We know that that is a valid conclusion because each of the lines has been justified by at least one of the rules. Now we move to a problem with more premises. These are problems that I like because they have as their conclusion a single atomic sentence. And somehow that makes it a little bit easier to get a grip on. Especially in this case, notice that the I occurs only in line 5. This helps you to develop your strategy. You know the I is going to come out of line 5, and so you ask yourself, what's the most reasonable way to get it from line 5? Since line 5 is a conditional, why not try modus ponens? To do modus ponens, this would require that we have the C. In other words, if we had C, we could get our answer I through modus ponens. So now the strategy is, where do we get the C? How do we find the C? That's, as it were, our intermediate target now to solve the problem. Well, we have to go back to the premises here and find out where we can get C. Notice where it occurs. We have it here, and so we could get it out of line 4 if we had not L. Could we get it out of 2? Well, it's possible, but notice that the most obvious thing to do on line 2 would be modus tollens. In other words, if we had not A, we would then get something C, but it would be not C, wouldn't it? And so that doesn't look as likely as pulling the C out of line 4. To get it out of line 4, remember, we'll need not L. Can we get not L? Well, hunt around and we see, oh, there's not L right here in line 3. So this is beginning to look pretty plausible. If we can get into line 3 with modus ponens, then we could get not L and not M and simply simplify that to get us not L. So that means, in order to do that, we need G or A, right? If we had G or A, then we could do modus ponens on line 3. So where are we going to get G or A? Well, notice that line 1 and 2 are two conditionals, and the G and the A are the consequence of those two conditionals. Now think about the rule constructive dilemma. I'll tell you something about constructive dilemma. It is, in my view, the hardest rule to see. In other words, to see its applications in the problem, mostly because the elements of constructive dilemma can be distributed across as many as 3 lines. But think about how the constructive dilemma goes. If you have the disjunction of the antecedents of two conditionals, here's a disjunction, L and C. They both are the antecedents of these conditionals. And if you have the two conditionals, constructive dilemma tells you that you can get the disjunction of the two consequents, which would be the answer we're hunting for, G or A. Remember, that was our goal sentence here, G or A. So it would appear that constructive dilemma on lines 1, 2, and 4 will help us out. That'll solve the rest of the strategy. So the last move here will be a constructive dilemma move. Okay, now basically we need to turn this strategy on its head and start by constructing first the constructive dilemma move. To do that, we need to bring 1 and 2 together by conjunction, because remember the rule says we need to have the two conditionals on one line. So we've got L hooks G and C hooks A on a single line, and we cite lines 1 and 2 conjunction. Now we have a line that allows us to apply constructive dilemma given that we have line 4. So we get G or A from lines 4 and 6, constructive dilemma. All right? Now remember, the next thing we wanted to get was the not L. And we're going to do that by a modus ponens move on line 3 that capitalizes on what we just proved on line 7. So line 8 is not L and not M, the consequent of this conditional on line 3. And we cite 3 and 7 modus ponens. Now remember, we want the not L at this point, so we need to simplify line 8. Line 9 gives us not L from 8. Simplification. Now we've got our not L. How is that supposed to help us? The not L, remember, negates one of the disjuncts on line 4, and so we get C from lines 4 and 9 by disjunctive syllogism. And now the last step, we get the I, which we're hunting for, by modus ponens with lines 5 and 10. I, 5 through 10 modus ponens. There we are. Another thing you'll notice here as we do these, This really is a step-by-step procedure, and your thinking process in order to solve the problem really has to be step-by-step. If you try to go too far ahead without knowing precisely how you're getting there, you're going to get confused and you're not going to remember the steps of the strategy. So anytime you feel like you've lost your way, stop, go back to where you feel you're certain about things, and try it again. And it's a good idea, as I've been doing here, to put down, say, on the edge of the paper, the steps that you're thinking about taking to see whether, in fact, the strategy leads to the conclusion. Okay, now we want to use all the rules of inference and do the derivation ourselves. The conclusion of this is a disjunction, and you should remember that you can conclude a disjunction if you could derive either of the disjuncts. You could simply then add the other disjunct onto it. So at first you may ask yourself, well, could we get either O or get L and then simply tack on the other? Well, let's look at what we've got to work with, and we'll see that's not going to work in this case too easily. To get the L by itself, we'd really have to be able to get into line 1 with modus ponens probably twice over. In other words, if we had P or Q, we could get K hooks L, and then we would be able to derive L if we had K. But notice, here's where K occurs in the other part of the problem, and it is disjoined to M. So we're not going to be able to free K up too easily here. Similarly, you're not going to be able to get O by itself unless you had not N. You could then do modus ponens on line 3, but to get not N, you'd have to have M by itself, and when you don't, K is disjoined to it. So this doesn't look too promising. Instead, when you have a disjunction and this kind of problem occurs, you should start thinking about constructive dilemma. With constructive dilemma, you generate the entire disjunction in one fell swoop, as it were. And so we need to ask, do we have information here in the premises that would allow us to do a constructive dilemma move? Well, notice we do have O as the consequent of a conditional here, and we have L as the consequent of a conditional in here. So if we could get into 1 and generate K hooks L from 1, we would have one part of what we need for constructive dilemma. And if we manipulated 2 and 3, we would be able to generate another conditional which had O as its consequent. That would put us in a position, perhaps, to use constructive dilemma. So let's see if we can get ourselves a little bit closer to that conclusion. The next thing to notice in this case is that 2 and 3 have that suspicious character that allows you to use hypothetical syllogism. Remember, they share here the not N. So by doing hypothetical syllogism on 2 and 3, we would get the line M hooks O. Now we have this conditional which begins, its antecedent is M, and let's assume we can get the K hooks L out of line 1. Do we have the other part of the constructive dilemma rule, namely the disjunctive line, which would in this case be M hooks K? And you look around and we find that that is line 5. So that looks real promising. If we continue with this strategy, then what we need to do is to get K hooks L out of line 1. We can do that, of course, if we have P or Q. And we already, in a sense, have P. Here it is on line 4. So we need first to simplify and get P out of line 4 so that it stands alone. And then we need to add Q to it. And of course that's easy. From P you can infer P or Q, cite line 7 and the rule addition. Now modus ponens on line 1 and 8 will give us what we were looking for, the K hooks L. That's 1 and 8. And now we need to join together 6 and 9 in order to have one line that brings together the two conditionals that are necessary to invoke constructive dilemma. So M hooks O and K hooks L, and that is line 6 and 9 conjunction. Now we have M or K, line 5. We have line 10, which is the other part of the rule constructive dilemma, and Together they allow you to infer O or L. And that's what we were hunting for, O or L. And we cite line 5 and 10. Constructive dilemma. Okay, look at this one. 12 lines long it looks like it's going to be. And we're hunting for not E and J. When you hunt for not E and J, one obvious way of getting it is to break the strategy up in half and basically hunt for not E and then hunt for J and then conjoin them. So let's see what we've got. Can we get not E? Let's ask ourselves that. Well, look around here. You see that's going to be simple because here's V. We can simplify and get V from line 3. Here's not E. V and line 2 will give us not E with modus ponens. So that's no problem at all. We'll get that right away. So we know how we're going to get not E. How are we going to get J? Well, you hunt around here and you see that J occurs only on line 4. We know we can get into line 4 with modus ponens because we've already decided we can get not E. So that would give us P or J, and we would then be able to infer J if we could infer not P. Disjunctive syllogism, right? Well, let's see what other P we have to work with. That's up here in line 1. If we can get into line 1 with modus ponens to create a line that said P hooks E, we would then be able to get not P because we've got not E. We could use modus tollens then on P hooks E to get our answer, not P. Having not P, remember, gives us the J. So now we look like we have something of a strategy. Let's, again, do the not E part first, solve for not E, get that out of the way, and then hunt for J. So we first of all simplify. We get V on a line by itself. That's from line 3, simplification. And then we do modus ponens on line 2 to give us not E. So that's line 2 and line 5, modus ponens. So there is half the problem. Now we need to get the J. Remember, we're going to get that by trying to get into line 1, first of all, and then ultimately use not P to alter line 4. So we need to have V and not E. We have that right here in 5 and 6, so we simply put them together, V and not E. We cite 5 and 6, conjunction. That, remember, gives us by modus ponens P hooks E, line 1 and line 7, modus ponens. And now we have the not E, remember, line 6, so we can do modus tollens on line 8 to give us not P. That is 6 and 8, modus tollens. Now how is that helping us? Well, remember, we've got P or J here, and we already have not E, so we can do modus ponens first on line 4 to give us P or J. Okay, and that is lines 4 and line 6, modus ponens. The not P negates this disjunct, and therefore we're allowed by disjunctive syllogism to infer J. That's 9 and 10, disjunctive syllogism. And now we're just about done. All we need to do is conjoin line 6 and line 11 and get not E and J, 6 and 11, conjunction. Okay, also, you know, repetition of the problems is really the only way of mastering this. If you get stuck on one problem, don't spend a lot of time on it. Go on to the next one on the test. See if you can work that out, and then come back. Often a fresh start is the best thing. Now we get to the real power of this system, which is the power of being able to take an English argument, translate it into symbols, and show that the conclusion of the argument validly follows. What we're doing here, in a sense, is combining that a skill that we learned in Unit 8, the skill of translation from English to the symbols, with the deduction skill that we have just been practicing. So we are going to do one problem of this sort, translate the following English argument into symbolic form, and then use the rules of inference to derive the conclusion. Okay, look at this. If Norbert is a genius, then he will publish another book. And if Oscar is depressed, he will compose a requiem. If Quincy is a good judge of character, then either Norbert is a genius or Oscar is depressed. And Quincy is a good judge of character. Hence, either Norbert will publish another book or Oscar will compose a requiem. Well, this seems really complicated. But, again, you go step by step. The first thing to do is to work on the translation. Figure out the conclusion, figure out what the main connectives of the premises are, and assign letters to all of the component propositions. So let's go back and see what we've got. Hence, here is the conclusion indicator. So we know either Norbert will publish or Oscar will compose is going to be our conclusion. Now let's work on the premises. Notice we have one sentence here, which is quite complex, another sentence here, and a third premise here. Let's work on the first one. What is the main connective? If Norbert is a genius, then he will publish another book, comma, right? So the and here shows that this initial sentence is going to be a conjunction of this first conditional and what? Another conditional. If Oscar is depressed, he will compose a requiem. Now we need to assign some letters. So let N stand for Norbert is a genius. And let P stand for Norbert will publish another book. Let O stand for Oscar is depressed. And let C stand for Oscar will compose a requiem. Now we know what the main connective is, so basically we know how to translate it. We need to say, if Norbert is a genius, then he will publish another book. Conjoin that, and what? If Oscar is depressed, O, then he will compose a requiem, C. So there's line 1. All right, line 2. If Quincy is a good judge of character, then either Norbert is a genius or Oscar is depressed. Well, notice this is a complex if-then. The comma indicates that the if-then is the major break in the sentence. And the consequent of this conditional is a disjunction, an either-or. Either Norbert's a genius or Oscar's depressed. So now let's assign some symbols. Quincy is a good judge, let that be Q. Norbert is a genius, we've already done that, remember, that's N. Oscar is depressed is O. So line 2 will then look like this. If Quincy is a good judge, then, parentheses, either Norbert is a genius, or Oscar is depressed. Okay, let's do the third line now. And Quincy is a good judge of character. So that simply asserts Q again. So Q by itself is our third premise. Now what's the conclusion? Remember, we can set it up here just like it's a problem in the book. The conclusion is either Norbert will publish another book. Remember, that is P. Don't get your N's and P's confused. Norbert will publish another book is P. Either that or what? Oscar will compose. Oscar will compose a requiem is C. P or C is what we're hunting for. So we've now translated the argument into symbols, and we then apply exactly the same rules of deduction as we did prior, and see whether we can get P or C out of here. P or C could be had, of course, if we could derive either P by itself or C by itself. We could simply then add the other element. But let's look at the premises and see whether we could get either P or C by itself. To do that, we'd have to have N in the case of P. Then we could use modus ponens here and get P. We'd have to have O to get the C. Are we going to be able to get N by itself or O by itself? Doesn't look like it, because remember, even if we work on line 2 here and get rid of the Q with modus ponens, we're going to end up with n or o, not either n by itself or o by itself. So this is beginning again to look like a constructive dilemma problem. We've got P or C, and notice that is the disjunction of two consequents of two conditionals. So that should put in mind the following idea. If I can get n or o by itself, I'll solve the problem. I can use constructive dilemma. And of course n or o is right here, and that's going to be a simple move. It turns out that we can get this answer in very few steps, even though it was an extremely complicated thing to initially translate. So let's go do it. A modus ponens move on 2 and 3 is going to give us n or o. We have a line on line 1 here. We have a line that says we've got two conditionals, and the two antecedents of those conditionals are precisely what we've just written here on 4. So 1 and 4 together will give us P or C directly. 1 and 4, constructive dilemma. Basically a two-step proof, even though very complicated premises. Now, that's the end of Unit 10. In Unit 11 through 13, you'll be doing pretty much the same kind of thing. In other words, you'll be doing a number of problems where you provide the justifications, a number of problems where you do the deductions, and one problem where you translate into English. The only difference is that as you go through the units, we add more rules and additional strategies. But cheer up, because the addition of the rules actually makes some of the problems easier. We'll see you then.